Today this lesson is going to cover scientific notation. Specifically, the Common Core standard is to perform operations with numbers expressed in scientific notation, including problems where both decimal and scientific notation are used, use significant notation, and choose units of appropriate size for measurements of very large or very small quantities. Interpret scientific notation that has been generated by technology. So today we're going to focus on a question that the students asked me while working through some multiplication problems on their calculator. A couple of the students noticed that while they were trying to do a problem, that the calculator did not give them an answer that they recognized. So the problem was, let's see. Alright, so let's go ahead and enter that into the calculator and see what we get. Alright, so as the student said, they did not understand this as an answer that they've seen because it includes the E in there. So, to solve big problems like this that won't fit all the numbers on a calculator, mathematicians use something called scientific notation. So, scientific notation is a very special way of writing numbers. You can write a number like 700 in scientific to 7 times 10 to the second, or a really big number to 4.9 times 10 to the ninth. It is a very easy way to write big and small numbers. Yeah. So let's look at how this works. So the first example that we talked about, 700, why is this written like this in scientific notation? So we have 700 is 7 times 100, and 100 is 10 to the second, which is about the powers of 10 that we learned last week. So 700 could be represented in 7 times 10 to the second. So both those are equal as seen below. So let's learn how to put it into scientific notation. So scientific notation involves moving the decimal place over to find out how many spots the power is to. So the number is written in two parts. Just the digits with the decimal point placed after the first digit, followed by times 10 to a power, and that puts the decimal point where it should be. Example, it shows how many places to move the decimal, which we'll talk about next. So 5,326.6 in scientific notation, the decimal was moved over 1, 2, 3 spots, making it 5.3266 times 10 to the third. So let's learn how to figure out which way to go when moving the decimals. Alright, so how to do it. To figure out the power of 10, think how many places do I move the decimal? When the number is 10 or greater, the decimal point has to move to the left, and the power of 10 is positive. So these are key things that we're going to want to remember when we're doing this. When the number is smaller than 1, the decimal point has to move to the right, so the power is negative. So an example of this, we're going to be moving this over 1, 2, 3 spots so that we have a digit on this side and a digit on that side. That's how we know to stop, making it 5.5 times 10 to the negative 3 because we moved it to the right, making it negative. Alright, and you can always check this on your calculator if you're unsure. You can always type it into your calculator and check to see if you end up with your original number. So, now that we've had a quick idea of how to do this, let's try a couple examples. Okay, so our first example, we're going to put our notes over here as well as we go through this. So this number is smaller than 1, so we're going to be moving it to the right and the power is negative. So we have 1, 2, 3, 4, 5, 6 spots to the right, making it 2.56 times 10 to the negative 6. We'll do the same thing over here. 1, 2, 3, 4, 5, 6, 7 spots to the right because it was smaller than 1, making it 1.4 times 10 to the negative 7. And the last one down here, we're going to be moving it 1, 2, 3, 4 spots. So making it 2.75 times 10 to the negative 4. So now we're going to do something different with this example. So since it is greater than 10, we are going to be moving to the left, starting right here. 1, 2, 3, 4, 5 spots, making this 9.2 times 10 to the 5th. Notice that it is positive because we did move to the left. Same thing down here. 1, 2, 3, 4, making it 5.2 times 10 to the 4th. And our last example down here, we moved 1, 2, 3 spots, making it 2.8 times 10 to the 3rd. So, as we go through these examples, we're going to actually head into the computer lab to the section on this lesson plan where we can try this. This will be a spot in the computer where we can put in our numbers and work to have it put in scientific notation. We are going to be making a bingo palette so we can play bingo afterwards with these, so we're going to make sure that we get all of our numbers correctly put in scientific notation. Alright, thanks for listening.